Hello friends, in this video we'll be discussing complex variable type 5 miscellaneous problems, and this will be our second example. So friends, this is our second example. First example is quite similar. The procedure is quite similar, only the values are different. So let's have a look on the given problem. F of z is equal to cos hz. We need to prove that it is analytic. The same problem we have solved in type number 1. We have already proved it that the function is analytic, but still I'm going to do it again, and I need to find f dash z and f double dash z. So as we discussed in the last problem, f dash z can be find it out by using Millen-Thomson theorem. So basically there are two parts. Let us solve the first part. F of z is analytic. So let us start. F of z is equal to cos hz. F of z will be replaced by u plus iv. Cos h z will be replaced by x plus iy. The same problem is already solved, so I'll be going bit faster here. So let us open the bracket. Cos hyperbolic, cos sin with the opposite sign, but when it is a normal cos, when it is hyperbolic, it is always the same sign. So it will be cos hx, cos hiy, sin hx, sin hiy with the same sign. We discussed this number of times. Cos hx will remain as it is. Cos hiy, we do have I in angle, and this is hyperbolic, so that will be converted into circular. I comes out in sin and tan. This will remain as it is. There is no I in the angle. Here I will come out, and this is hyperbolic, will be converted into circular. So after equating, you will get the value of u as cos hx, cos y, and v is sin hx, sin y. So we need to check CR equations are satisfied or not. So ux is y constant, cos y constant, cos hx is sin hx. Vx sin y constant, sin hx is cos hx. Uy cos hx constant, cos y is minus sin y, and Vy sin hx is constant, sin y is cos y. Now friends, check. These two terms are equal and they are opposite of each other. That means ux equal to vy and uy is equal to minus vx. Therefore, CR equation satisfied. Also, function partial derivatives are continuous. Therefore, function is analytic. So nothing new in it. We have already done the same thing in type 1. Now we'll find it out f dash z and f double dash z. So f dash z can be find it out by using Millen-Thomson by mt. F dash z is equal to phi 1 z comma 0 minus I times phi 2 z comma 0. Right. So phi 1 is actually, this is ux z comma 0 minus I times uy z comma 0. This is your empty. See, actually there are two empties. One is with respect to u, that is f dash z is equal to phi 1 z comma 0 minus I times phi 2 z comma 0, in which you need to consider ux and uy. There is one more formula, that is f dash z is equal to phi 1 z comma 0 plus I times phi 2 z comma 0, where this is vy z comma 0, vx z comma 0. So either you can go with this or with this. So if you're using this formula, first one for finding f dash of z, so you need to take both u partial derivative, and if you're going for this, then you need to use both v derivative. So here I'll be using the first formula, that is this one. So f dash z is ux z comma 0 minus I times uy z comma 0. First of all, let me have ux x comma y is equal to cos y sin hx, and u of y x comma y is minus cos hx into sin y. These are the values. So ux z comma 0, you're going to replace x with z and y with 0. So y with 0, this will become cos 0, that will become 1. So this is sin hz, and uy of z comma 0. So friends, if you replace this y with a 0, this will become sin 0, and sin 0 is 0. So let us put these values in this equation. So f dash z is ux z comma 0, that is sin hz, minus this particular term is 0. So f dash z is basically sin hz. So this was asked. One more term asked is f double dash of z. So how are we going to get that? Just differentiate with respect to z again. So you're going to get f double dash of z. So sin hz derivative is cos hz. That's it for this video. Thank you.